Hey students, welcome back to our channel Day Study Shade, and in today's video we'll be discussing the sixth subject of Icse, which is computer application. So as we all know that the part of the syllabus for computer application class 9-10 is Java. So we'll be discussing the most common questions or the most easiest programming questions which might come in your board exams, and it's mostly dedicated to class 9s because these are the programs which you all learn at the very beginning. At class 10 we tend to teach you more of advanced level questions. This is the very basic 5 programs which we'll be discussing. Class 10s are free to watch it, but it's mostly dedicated to class 9s. The programs will be easy. I'll be showing you the codings with outputs. So I hope you will benefit from this video. So before starting, I would like you to subscribe to my channel, like this video, comment and share it with your friends. So let's get started. So yes, the first question which we'll be discussing is Armstrong number. Now first let us know what Armstrong number is. Armstrong number is like a 3-digit, has an integer that is the sum of the cube of its digit, which is equal to itself. Like for example, the question might be intimidating and a bit of confusing for you. 153 is an Armstrong number. Why is it called so? See, 1 cube plus 5 cube plus 3 cube is equal to 1 plus 125 plus 27, which is equal to 153. So it means that the cube of each digit should be equal to the number itself. This is what the programming is asking us. We enter a number and we compile, and the compiler checks it that if it's an Armstrong number or not, or if its digits are equal to the sum of its cubes. So let's see the coding. So yes, we are starting with the class. We have named the class Armstrong. You can name it anyhow, but it will be best if you name it which has a suitable name for the program. Then we are assigning a value int n, which we'll be accepting from the user. Then we have int a, b and d. So we'll be assigning a equal to n, which means the value entered by the user will be assigned to a. We are using a while loop in this case. Obviously, while loop has to be used here. So with while n not equal to 0, it means we'll continue the process till n is not 0. As soon as n is becoming 0, the loop will end. We are extracting the digits to d. So d equal to n modulus 10. So we got the last digit. We are considering 153. We got the 3. So d equal to 3. Now we're dividing n equal to n by 10, which means now we have 1 and 5. 15 as the number and the 3 has gone. Now b is the number which will be calculating the sum of the cubes. So we have b plus d into d, which means d cube. So obviously this loop continues till n is equal to 0. As soon as the loop ends and we get the final value of b, we will check, or the compiler will check, if a is equal to b, which means a is equal to b or not. Remember, we cannot use n equal to b because n's value has been changing while the loop was running. So now we'll be checking if a is equal to b, since we have assigned a equal to n. If a is equal to b, the compiler will print that a is an Armstrong number. And if a is not equal to b, which is else, it will print a is not an Armstrong number. I hope this programming is very clear. It's a very easy program. Usually when this kind of questions comes, they come in 2 parts. This might be one part of the programming question in section B. So yes, we started with 2 examples. First, I entered 152. And obviously the compiler returned that 152 is not an Armstrong number. Whereas as soon as I entered 153, it said 153 is an angstrom number. You can copy this program down and check it in your own system under BlueJ Java and then see if the output comes or not. We move on to the second one, palindrome number. Now palindrome number is very easy. Palindroming number is basically a number which remains the same when its digits are reversed. It's like a mirror image. See, 16461 will be equal to again 16461. Or if we take a number like 11, its reverse will also be 11. Or we take 121, its reverse will be also 121. So it is like symmetrical number. See, I've mentioned symmetrical number. Easy one. So try to see what do we have to do. Think about it. We initialize a class. We accept a value from the user. We run a loop. Check. We first reverse the number. Then we check if the number accepted from the user is equal to the number reversed. So easy. You know, whenever you work with a program, try to jot the process or try to jot what are the things which we have to do. And then your writing your program will be very easy, because in the exam hall, you won't have your machine in front of you. You'll have to write it down. So if you miss out any step, you will get marks deducted, because marks are assigned for each of the steps in computer. So yes, the coding, we have first initialized the class to be palindrome. We took void main int n. So n is basically the value which the user will enter. We have assigned int a equal to 0, b equal to 0 and d. D is for the digit to be extracted. Similarly, like the previous program, I have assigned a equal to n. So for n, see, not equal to 0, n will be divided by 10. Okay. So d will run as d equal to n modulus 10, b equal to b into 10 plus d. See, this is a similar thing. You can also use it in a while loop, but I have done it in a different way, for loop, so that for you to, understand in a different way if you are not comfortable with while loop. Then we are checking, since we got the reverse value in b, we are checking if a is equal to b. And as soon as a comes equal to b, it will show it is a palindrome number, else it will show it's not a palindrome number. So let us check out the result. See, 121 is a palindrome number, whereas 123 is not a palindrome number. Easy one. So let's get to the next programming. Prime number. Obviously, you know what prime number is. Does not need much of an introduction, but okay. See, I've written it down. Prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. Okay, natural number is greater than 1 that is not a prime. It's called a composite number. See? So now we'll be checking the code or the coding programming for prime number. So we have taken class prime. We took void main int n, or the number which we are accepting from the user. We also took int d and c. See, d will be for the extraction or checking if the number is divisible or not, and we are checking c to count the number of factors. We are running a simple loop, for loop, int I equal to 1, I less than equal to n, I plus plus. Then what we are doing is we are checking with all the numbers starting from 1 till the number itself. We are checking n mod. See, if for instance we'll see n mod 1, n mod 2, n mod 3, n mod 4, like that it will go on till the number. And if the mod or the quotient, if the remainder is 0, obviously it is divisible. So C will become C equal to C plus 1, or plus 1 get added. Since we know that more than 2 factors of a number is not a prime number, so if C is equal to 2, it will be a prime number, and if it's more than 2, it will be a composite number. Very easy programming. we'll check a result or an output. See, I've entered 3, it shows it is a prime number, whereas when I enter 12, it shows it is a composite number. We'll obviously be discussing a programming which is for the factors, a similar kind of a program where we find out the factors. See, this is the factor program which will be showing. It has the same kind of a concept being used. We have to find the factors of a number. So yes, we take a class factor, we take a void main, int n, accepting the number from the user. We are running a for loop. Then we are considering a to check the divisibility of the number. Similarly, when we are seeing that the remainder is 0, if a equal to 0, we'll print it I plus space. I have put a space so that the numbers are not clumped up. It does not show as a one number. So as soon as you are printing any number, its factors will be printed. So let's see the outputs. See, I had entered 6, it showed 1, 2, 3, 6. All are factors of 6. As soon as I entered 30, its factors from 1 to 30 are out. See, all are divisible by 30. Okay, next programming. Perfect number. Okay, this must be new for many. So perfect number is basically the number theory or positive integer that is equal to the sum of its positive divisors, including the number itself. Okay, it's like more of all the factors being added up to equal to this number. See, 1, 2, 3, all are factors of 6. When they are added up, it becomes 6. We are leaving out the number itself. We are only discussing the factors apart from the number itself. So 6 is basically a perfect number. So we'll check the programming. For this programming, we have to accept the number, find out the factors, find out the sum of the factors, and then check with the number if the number is equal to the sum of the factors. So yes, class perfect, void main int n, a, b, c. Taking many variables in hand is easy or handy. So whenever you are doing a program, it'll be easier. When you have an excess variable, it won't affect much. You can use it at any point of time in your programming. So I would recommend you always to take 1 or 2 variable extra so that you don't have to draw a line extra and write a variable at the end. So again, we are running a for loop. We are finding the divisibility, and just like the previous programmings, we had been adding c equal to c plus 1. Here we are adding c equal to c plus I. It means that if the number is a factor, it's getting added. Also note down, we are not doing I equal to less than equal to. We are just doing I less than n. It means that the number which has been entered won't be running in the loop. If the number is 6, it will run till 5. If the number is 20, it will run till 19. It means less than. So obviously, if the number is found to be equal to n or the number entered, it will print as a perfect number or not a perfect number. Let us check output. So yes, as like the example I had given you at the very beginning, 6 when entered will show it is a perfect number. Whereas 35 is not a perfect number. We know 1, 5 and 7 don't sum up to 35. So obviously it is not a perfect number. So with this we come to the end of our first session of computer. I hope you liked this video. Give it a thumbs up. Subscribe to my channel. Also you can write your comment in the comment section all your doubts.